on V, 2 find omega.
Yeah.
I use T equal to
2 pi over T.
Omega.
To find T equals 2 pi over omega, yeah.
Yes, so the omega is 2 pi over T, right?
Yes.
So using the T that one
Yes,
I found
yes,
on
yes,
A,
yes, 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 yes.
what did you got?
Well, I'm going to do it now. I'm going to do it now.
But
Yes?
the T in the formula for V equals a
That is for a particular time of your choice.
summation.
Yeah, like, for example, I say, how fast is it going at half a second?
So I don't have to use the big T.
No, the big T is strictly the time for one oscillation, and the small t is for a particular time.
If you say maximum velocity, there is no particular time.
No, there is a time when it's at its maximum velocity, and if you think about its motion, you can figure out when is it going its fastest.
Oh, the velocity is of the F, so it's plasma zero?
Yes.
Oh,
I'm going to do it now. Let's start with A.
that's right.
Watch, I'm going to do it now. A. What is the time? Okay, so that's 2 pi root L over G. So that's 2 pi root 0.82 over 9.81, which is, Sean?
1.8.
Oh, give me more.
Second. 2.
Thank you, but I meant more numbers.
Oh, 1.8165117.
Okay, that'll do.
1.82.
1.8165.
1.
Okay, that's good, yeah. Yes. Okay, so that's the first part. 1.8165. Now, part B is what is the maximum velocity. So as it's swinging, here is the maximum
Middle.
V, the middle, correct, when the x is 0.
Oh, yeah.
So, using the formula V equals omega root a squared minus x squared, but the x we said is 0. So the maximum velocity is omega a. Omega is 2 pi over T a. This is 2 pi over 1.8165 multiplied by a, which in the question is 35 millimeters. Let's calculate that.
Oh, really?
Did you use meters?
So I just use 35. Not
Yeah, so it's like you did 35 meters.
Yeah, I am.
1.8165 times 35 times 10 to the power of minus 3. 0.121. And at which position will this occur? Well, this is when x equals 0 for part C. So part C is when x equals 0. Yeah.
So, in part B, you can't use the Euler formula for V,
Yes, you can actually.
but you don't know
V equals A or minus A omega sine omega T.
Is it kind of confusing if you say X because on harmonic version you say S?
I keep
know
switching
S
between
is
the two,
X.
don't I? I should really perhaps just stick to using X all the time.
I know X is X.
There. Happy.
Happy.
Okay. Monica, in the formula A omega sine omega T, you're looking for the maximum V. Now, we haven't done this with maths yet, but what's interesting about the sine function here is its value is always between minus 1 to 1. So it means the most that this could ever be is when this is equal to 1, because these are constants you can't change. So as it's swinging left and right, this is swinging from minus 1 to 1 in value. So the maximum possible is when this is a 1, which makes it A omega as well. Okay. D. What's the maximum acceleration? And E, which I'll do next, is where will this occur? Okay, so where is the maximum acceleration going to be? At the ends, yeah. So in other words, when x, or s, is equal to the amplitude, the a, yeah. Okay, so let's calculate the value of the acceleration. So using the formula a equals minus omega squared x, but I don't care about the minus because I just want the maximum. So that means a max equals omega squared a, which is 2 pi over t squared a, which is a lot like what I just typed in a moment ago, except it's a square. So if I just go back to my calculator and put brackets here. Whoa. Oh, thank you, Monica. The 35 should be... 35 should be outside it. Like this? Okay, so the maximum acceleration is 0.4188. Okay, now we're on F. So F, I'd like you to try before I do it, a sketch of the energy graph. And try not to look at your notes. Try to draw this without looking at your notes, F. Okay, did you make the graph in F? The energy graph. Do you know which graph this is, Jerry? Maybe? Oh, no looking. She doesn't know. This one here. Quadratic?
Yeah.
Huh? Do you need help with this one while I do it? I don't see many graphs. Right? Okay. F. Sketch the graph of energy against displacement showing kinetic, potential and total during one cycle. Okay, so here on the y-axis this is energy measured in joules, and here on the x-axis this is displacement measured in meters. So this is an A, this is a minus A. The kinetic energy. At the beginning, the energy is all kinetic, and all potential. At the beginning, it has no kinetic energy because it's at rest. Then, as it swings to the center, it gains more kinetic energy, and then loses kinetic energy until it's at rest again. So this is kinetic energy. Potential energy runs the other way. Maximum at the beginning. Whoa, nothing down here. This is potential energy. And total energy, which is kinetic energy plus potential energy, is just a straight line here. Let me move my E a little bit so. So this axis here is the axis for energy, and this one here is for displacement.
Is your word
T,
Oh,
total energy, yes. Okay, G. What is the total energy if the mass is 45 grams?
1 over 2 times 45 times 10 over 10
10?
minus cubic.
What?
It's M, I mean, 1 over mg plus mgh.
1 over mg plus mgh? What is
Oh no,
that?
wait, 1 over mv squared. I'm mechanic and
Go for it, Jerry. What's the formula?
half and
Thank you, Jerry. That's the one. So for part G, I want the total energy. Yeah? No. It's okay.
yeah,
Is it?
I mean, they used to be
Oh yeah. Yes. Oh, we have Mika. Your number? Yeah.
Isn't it the kinetic plus potential?
Yep. Okay. Here's the trick for G. The total energy is the kinetic plus the potential.
Yeah.
But you should pick a point when the potential is 0,
Yeah.
because the energy doesn't change. So we'll choose here to find the energy.
Yeah.
So then it's just a half mv squared. And you know the m and the v from earlier. So it's a half times 45 times 10 to the minus 3. And the v we had earlier was 0.121. (45 times 10 to the power of minus 3 squared). No. Let's try that again. 45 times 10 to the power of minus 3 divided by 2 times v squared divided by 10 to the minus 3 gives me milli. No, that's even milli small. 329 microjoules.
We can just leave the answer.
Yes,
Okay.
but I like using prefixes. They make me happy. Don't rob this from me.
What is
This?
Yeah.
Micro.
Micro.
Oh, we-
Micro.
You know micro?
Yeah.
Okay, good. H. What is the length if the frequency is 0.75?
Yes.
You got an answer?
No.
Okay. You can't, okay. Okay, so here the frequency is 0.75. That means the time, which equals to 1 over the frequency, is equal to 1 over 0.75, which is 1.333. Isn't it? Yeah. So that means 2 pi root L over G equals 1.333. So that means root L over G is 1.333 over 2 pi, and then I'll square both sides, so I get L is equal to 1.333 over 2 pi squared times G. Yeah, so all the 3's divided by 2 divided by pi squared times 9.81. The length is 44 centimeters. Okay. What was that? H. Alright. What would happen to the time if the bob was replaced by a bob of the same shape and size but twice as dense? Basically, you have a bob here of 45 grams, and you replace it with one of the same shape and size but twice as dense. The density is bigger.
Yes.
Twice as dense means it's 90 grams.
Yeah.
What would happen to T?
You see,
Very good. Why?
because
Nothing changed.
Yeah, nothing changes in the mass is not important in the formula, so it doesn't change. So the answer is nothing.
Teacher,
Yeah,
on H, do you have
no change. Yeah,
H, did you change that centimeter to meter, or you just got 0.442?
it's 0.442 meters or 44 centimeters is the length. Yeah,
Oh, that was fine.
yeah. What would happen to the time if the amplitude was halved? So if the amplitude was divided by 2. So instead of starting here, it starts at a smaller angle. What would happen to the time? Same what? Nothing. No change. Well, the formula for the time does not depend on the amplitude. It only depends on what? The length.
No.
Yeah. I'm going to give you 2 more parts here for fun. K. Calculate the maximum angle.
Okay.
I just made it up. Just right now. See? Look, there it is there.
And
Angle. It just made it up.
go.
Yes. The theta.
Oh, okay.
I want you to calculate the maximum theta. Okay, guys, I drew it for you, so you have everything in the picture here. So, there it is there, look. There's the picture of what's happening. So the answer is sine inverse that over that. Yeah? Should be small, like 2 degrees.
Yeah.
2 degrees, that's it.
2.44. Yes.
2.45. Okay, tiny. 2.45 degrees. Yeah.
What if I use this formula? Can I get the same answer?
For V?
For G?
For G?
Yeah, for B.
But it's harder.
Oh,
Okay. L. In part L, I want to know what is the maximum height.
Huh?
Yeah, here in the picture, see?
Oh, yeah.
Now, I know what we're saying is that the height is roughly 0 because we're considering it moving on a straight line. But if for a moment we didn't consider it moving on a straight line, we could actually work out the maximum height. Because if we look here, this is 0.82 from the top to the bottom. And this is 0.82 cos theta. So this distance here is 0.82 minus 0.82 cos 2.45.
Yeah.
0.82 minus 0.82 cos, answer here. So this should be very small, like 1 centimeter. Oh, not even 1 centimeter. It's not even 1 millimeter. It's 747 millimeters. So this is why it's okay to consider it to be about 0, because it's such a small distance as it turns. Yeah. Mm-hmm.
About amplitude, I know the amplitude means double B, right? Kind of like this.
Yeah.
But in vibration, it looks like this and this much, right?
No, it's the vertical.
Vertical.
Yeah.
So
Yeah.
in pendulum is
Horizontal.
horizontal.
Yeah. Yeah.
So
Yeah.
that's the difference.
I suppose that's the difference. Yeah.
I know that's the difference, but
Something to be
I
careful
guess
about.
like this way, pendulum goes like this. So we just count this.
I suppose technically, Chrissy, if you look at the vertical motion, it's also simple harmonic motion. It's bobbing up and down vertically. So we could use the word amplitude vertically, but in this context it's roughly 0. Because, I mean, that would be like the amplitude vertically, which is not much compared to the length of the pendulum, 82 centimeters. Okay, let's go on to number 2 now. 2. A student performs an experiment in which they change the length of a pendulum and record the time taken to complete 10 oscillations. The results are in the table below. Different lengths, different times. Part A, I'll let you try this. Show how to rewrite this into this form, where x is length and y is t squared. Okay, I'll give you a minute to try that.
Y is length.
Okay, any success? Almost? Yeah,
It's almost T, right?
exactly. It worked out to be 0. Yeah, so if you square both sides, you get t squared equals 4 pi squared L over G. Yeah. So if you want, this is t squared equals 4 pi squared over G L plus 0.
Yes.
So this is like y, this is like slope, this is like x, and this is like c.
Yes.
Part B, extend your table to make in a suitable manner. Okay, so let me just copy the table here. So we have length, which is in meters, and then we have the time for 10 oscillations in seconds. Okay, what are my lengths? 1, and then it decreases by 0.1 all the way down to 0.1. Is it? Okay, and now the different times. 19.98, 19.02, 18, whoops, 19.02, 18, 16.69, 15.45, 14.24, 12.73, 10.98, 8.93, 6.31, okay, no, it's okay. Now, extend the table means, write something with the table, make the table bigger. So what do I need to add to this table? What do you think would be appropriate to add to this table? Well, the length is fine. There's nothing wrong with the length. The length is the length. But what's the small problem with the time? It's for 10 oscillations, and in the formula it's for 1. So what would be an extension of the table here? I should have t, and this should be y exactly. This one, divided by 10.
Yeah.
Yeah? Okay, so I'll just give you a minute. You want to add this in, you can write it in under. But before you, well, not before you do, but there is something else to add to the table. Yeah. But my table's not quite finished because I want to make a graph. But here's my problem. We know that t equals 2 pi root, that's not the door, was it? No, t equals 2 pi root L over G. If I was to make a graph, this is going to be the problem, that's how to resolve it. If I was to make a graph where I put t here and L here, it's going to be something like this. It's not going to be nice. But if I make a graph where I put t squared here and L here, I'll get a perfectly straight line through the center. Because a moment ago we just proved that we can go from here to here. And if I call y t squared on my graph, and if I call x the length, then this graph is of a straight line. So by plotting t squared against L, I'll get a straight line graph. And what will be the slope of this graph? The slope of this graph will be 4 pi squared over G.
Yeah.
So with that in mind, what's missing from my table? T squared. So now, t squared in seconds squared will be this squared. That's a bit too much for, let's put it to, I don't know, 2 decimal places, I think. No, that's not enough. No, yes, maybe 3. Okay. There we go. So this is what we'll need to plot in a moment. So let me just copy this, put it here, paste numbers, text. Oh, no, go back. Right, paste numbers. Okay, that goes there. And let's delete this. There we go.
That is 0.
OMG, how did that happen? How did that happen? Alright, let's try that again. Copy, paste, numbers, that goes there, delete columns. Okay. Alright, so this is what we need now. You should write this down. T squared in seconds squared. Oh, now you do? Your teacher just said square the time. Why? Yes, exactly. The pendulum experiment. Which you'll be pleased to know is one of the 4 experiments you do here. There's a very good reason I picked this experiment for us to do. 2 very good reasons. Number 1, it's cheap. Yeah. And number 2, it won't hurt you. And number 3, it's easy, yeah.
Which is not good.
Most important things when I was designing the experiments is that it's cheap and it wouldn't hurt anybody, because you know students.
But you have to write.
But we want dangerous now.
Well, there's some experiments on the course that involve radiation. I decided not to do this.
We want that.
Yeah, no, I thought maybe so.
Yeah.
What else? Yes, there's something where you have to heat up materials to calculate the heat capacity. Again, I didn't want to burn the school down, so...
We're going to do experiments here, right?
Yeah. Yeah, I have the equipment in the office. There's only 4 experiments we have to do.
Oh, not DIT.
No, I used to do it in DIT until I discovered how much they charge, and I'm like, what? They charge thousands and thousands of euros to do the experiment, and I'm thinking, but I can just buy a pendulum for 50 euros. The stand is actually, you know, the retort stand is actually expensive enough, you know. The most expensive thing is the box of weights. to have for the Newton experiment with the trolley. Believe it or not, the cheapest thing is the voltmeter and the ammeter. They're only like $10. They're very cheap. Okay, did you write this down now? So let's make the graph. Now you'll have to make graphs in the exam. Okay, yeah. So you have to do this on graph paper, but I will make a nice graph here in Excel. So what goes on the X and what goes on the Y? Yeah. Okay, now, this is everything you need for a full graph. You need a title. So what title do we have here? I'm going to say periodic time squared against length. And this is for question 2. And the x-axis is the length in meters, and the y-axis is the time squared in seconds squared. I don't want a legend, and I do want x and y. Nice. Okay, let me just shrink this down a bit. And let me just make it a little bit bigger. Okay, and then you need to put in a line. And this is the graph here.
Yeah.
Yep. Now, that answers part C. So finally, for part D, using your graph, calculate G. How could I do that? Monica, you might know since you did the experiment. Yeah. Yes, that's it, yeah. So remember that we said slope is 4 pi squared over G. So that means G is 4 pi squared over the slope. And the slope is the rise over the run, or the height over the base. In other words, if you have a line, the slope is this number divided by this number. So let's have a look at the graph. Whoops. Oh yeah, I might need my calculator. Okay, so let's go from here, which is a 4, down to here, which is, what would we say, 0.25? Why not?
Use
No. In the exam, they want you to use 2 points from the graph. Because although you can't see it, this line doesn't match the points perfectly. There's a bit of an error. I didn't make the error strong enough for you to notice in this graph. And then the x is 1 to 0.1. Yeah? Yeah. So the slope is this number.
Yeah.
And we said the g is 4 pi squared over the slope. So we have fraction again, 4 pi squared over this answer I just got. Okay, let's see how good this is. Reasonable. Reasonable. 9.47. Well, not that reasonable. I think how... close enough. Yeah. Okay. So what we'll do is we'll just continue, but we'll just finish a little bit earlier today then. Alright? Okay, so that was all of the mechanics. Just roughly add this into your notebook. You don't have to have it so neat, but just a quick sketch into your notebook and then we'll finish it here. We'll look at some questions now.
Bowling.
No, linear motion would be the best description.
Linear motion. Because sometimes it's going like that. And it's
For that motion you can model it as circular, but there's actually something quite complicated happening there that causes the ball to do this, something that to do with angular momentum. It's quite advanced. when the ball travels in a straight line, if you give it a spin, so it's spinning as it travels in a straight line, that's what causes the path to curve. The same thing in football and baseball, when the ball curves in. It's quite difficult to do because you want to give the ball a spin, but still have it traveling in a straight line while it's spinning.
And then we have the cause of friction too, because they put oil on the bottom line.
The friction will be quite low for a bowling alley, which helps give it this curve effect. Yeah.
When we did this experiment, we used to be told that the graph should touch
The origin.
minimum of 2 points. Like if your curve could be the line has an error.
I wouldn't say that. There's no need for the graph to touch any of the points technically. It needs to pass, pass through the points is the key thing. So like you could have a situation like this, Monica, where you have maybe something like this. So when you draw the line, it passes through none of the points. Well, I accidentally got the last one. No, there's no requirement. In fact, technically and mathematically, the only requirement is that the line passes through the point which would be the average value of L and the average value of the t squared. This is the only mathematical requirement. Your teacher might have just been giving you a tip to help you draw it, but I don't see it necessary. It should pass through the origin, but in real life it won't exactly pass through the origin because of small errors moving the points around. Okay, let's just save this. This is for question 2. Oh my goodness. What is wrong? Maybe I'll try it as some. Oh. Right, let's try this again. Let's try this again. File. Save as. Desktop. Whatever. Question 2. Okay, good, I got it. Alright.